Saturday?
Are you interested?
You guys look so little.
Was this weekend?
I wrote, okay,
The opportunity to get 10 extra points.
no, I didn't go to, I didn't know it was this kind of variance.
Exactly, yeah. They don't even need to be the same size, it can be right with you.
You guys ready? Are you guys ready? No, you're not ready. We've already done this, right? We already applied Gauss term elimination to augmented matrix. So if you don't mind, can I erase this? I want to show you a whole new way to solve the system. I'm going to start off with a simple example that's a 2x2, and I promise my next example will be slightly more sophisticated. So I maintain, like I mentioned yesterday, if I can rewrite a system equations this way, ax bar being equal to b bar, if I do have something called an inverse matrix, what I could do is multiply both sides on the left-hand side by that inverse matrix. Whoops. And I can do it correctly. I really can. It's just that, yeah, I'm sorry.
Since we don't know if this is a square matrix or not, do we have to say that that's the left values in order to do it?
You see how comfortable
Because we don't know if it's a square matrix, do we have to say that A inverse is rather the left inverse of A?
No, that's my mistake. Solve the system, I really meant A to be a square matrix. So it is a square matrix. And I maintain that we've got the law of associativity. Somebody asked me to prove that, I forgot. Still forgot. I'll get that today. It's just if you take a peek at the left-hand side, if an inverse matrix really does exist, we expect this product with the original matrix just to be the identity matrix of the appropriate size. But the identity matrix is acting as a number one in the real number system relative to multiplication. I'm simply going to get my x bar completely isolated. My point is this. If I can merely find an inverse matrix for the coefficient matrix, then let's multiply the b bar on the left-hand side by its inverse. We'll be done with it. I think I can do it. After all, taking with my black pen, if it's working, cheapers. Works. Oh, better. So everybody, let me take my coefficient matrix, which is 2, 3, 5, 2, and I will augment it with the appropriate size identity matrix. Here it is. Today we don't have a lot of time. In class today, I'm merely going to be very structural, not theoretical. I'm going to walk you through these processes. Now, I'm going to massage this augmented matrix in such a way that I'm going to force the identity matrix to exist on the left-hand side of the bar with my basic elementary operations, and what remains on the right-hand side will be the inverse matrix. So, here I go. I'll multiply the first row by 1/2. I'll multiply the first row by -5, add it to the second row, use the results of my new second row. Does that give me a 0? Is that a -11/2? Is that a -5/2 and a 1?
Yeah.
And then, does that give me, I'll use this middle ink board. Does that give me a 1/3? 1/2 0? And you guys, as I continue writing, can I just multiply the whole second row by -2/11? It forces the second entry to be a +1. But I suppose that's going to give me a +5/11. And then we have a negative 2 11ths. Oh, you guys, I'm one step away from finishing. I will now take the second row. Multiply by, whoops, negative 3 halves. Add it to the first row, use the results from any first row. That's going to generate this. 1 and a 0, and then I have no idea what's next. Negative 3 halves times 5 11ths plus 1 half. You guys, I get a 7 11ths. Maybe not. I think it's a negative 4 11ths. And then my negative 3 halves times my negative 2 11ths plus 0 is merely going to give me, oh, I see this, positive 3 11ths. I maintain the inverse of the original coefficient matrix is nothing more than what you see to the right-hand side of the vertical bar. And so for me to come up with my solutions, I think x bar is going to be the product of the inverse matrix for A times my b bar, but the inverse matrix for A, I just found to be negative 4 3. 5 negative 2. And my b bar was, I forget, is that 11 11? Wait, what?
What happened to your denominators?
Oh shoot, you're right, I forgot about it. But I'm tired, I don't want to do fractions. So can I just pull it out? That's what it means to have scalar multiplication for matrices. And I guess that gives me 1 11th times, here we go you guys, watch. It's a 2 by 2. That's a 2 by 1. I don't think I'm making any mistakes at this point. Multiplication is defined because the number of columns in the first is equal to the number of rows in the second. But I think the resulting product matrix is going to be of dimension number of rows in the first by the number of columns in the second. I think it'll be a 2 by 1. Let's talk about these entries. The first one, and the product matrix is in the first row, first column. So I use the result of dotting the first row, the first with the first column, second. Ah, but shoot, that just gives me negative 44 plus 33 is a negative 11. Now I think as far as the entry in the second row, first column, that's the result of dotting this row with this column, but that's just going to give me a 55 minus 22 is 33. I hope. And in the end, I guess it's merely going to give me a negative 1, comma 3. Yes, Chris?
That's cool, but why does that method work? Or can you show that tomorrow?
Yeah, I can show you tomorrow. Tomorrow I'll also show you a shortcut, unless I think I'm thinking of the quizzes we think of.
I don't think that works though, because if you plug that in for the first, like negative 1 for x.
Thanks. It's just a 2 by 2, so you just plug these things and check to see if I'm correct.
Real quick, what did you do between the third step and the fourth step to get rid of the, to make the 3 halves a 0?
I did this. I multiplied the second row by negative 3 halves.
Oh, okay.
Add it to the first row, use the results from the first row. That's what I did. So you guys, let's do just that, let's check them. Plugging in for x, negative 1, and 3 in for y. You're right.
It should be positive.
There's a mistake. When I created this example, I think I had in my head 1, 3. Is 1, 3 going to work?
Yeah.
Yeah, it does. I made it up out of thin air.
The negative 4 11 would be negative 2 11.
Is that what it is? Can I check it real quick? Well, that's what I did here. So negative 3 halves times 5 11ths plus 1 half. That's negative 15. Really? It seems that works. Negative 15, 20 seconds. Plus a certain number of 20 seconds, which is 11 of them.
Yeah, you put it over 11 instead of 22.
That's it. So I got a negative 420 seconds. I see. I'll change it to blue so you can see my mistake. I apologize. So I'm going to change things dramatically a little better. If I change this in blue to a negative 2, what happens next? Is that a positive 11? What about the next one? Oh, it doesn't affect the next. I guess that fixes it. nothing compared to what we're gonna do next. So,
Oh, wow.
do you mind?
Right.
You do mind. I've got 10 minutes, I can do this.
Is there a solution that we're just gonna rocket? But this is 1-3. The rocket. It's a set.
You guys, there's not much time in class left. I don't know if I want to really rush this. Instead of going through this long, involved, tedious process, which I told you I'd post my examples online for it so you don't have to write all this garbage down, you can just kick back and relax and let me do the arithmetic. Maybe it's this. Daniel asked me a question today. I was in the math center. I had so many people on me, and particularly people in class this morning that had an exam. I didn't get to his question. Can I go back to the homework? So homework. Can you, and I proved disassociative property for multiplication of matrices. But you guys, by the end of this weekend, I'm hoping you're a bit more sophisticated going through the homework set. I want you guys to be more theoretical. Besides, this statement is a statement about matrices of any size. So I don't want to give you specific matrix A, B, or C, or even a specific dimension. So, and that being the case, I think I should take A, B times C, and in English, look at an arbitrary element in that resulting product matrix in an arbitrary row and an arbitrary column. Do you guys see my point? And I maintain that this is going to end up involving multiplication. I'll go back to the definition. And I think my definition of multiplication says that second entry is going to be a C sub, I don't know, what is it, KJ is what we call it for? And I'm summing together something else with the subscripts IK, so I'm in the ith row, jth column, ranging over the K values so that dot product multiplication is defined. And this is going to be true as K ranges from 1 to, I don't know where K is going to range from, 1 to P, because I think it's the number of rows of the last matrix. Oh, but shoot, you guys, look how sloppy I am being on the board. I got the question mark in there. The reason why I'm stalling, because I think when it comes to question mark, that's the result of another product operation. And if it's a result of another product application, I think what I should do is insert there what that product is. Can I slide my C's and KJ over a little bit? So let's talk about that product. Remember, the subscripts are I and K. I think that's going to be the result of summing. Something like an A sub I question mark times a B sub question mark. What was it, K?
K.
But I got to put something in for the question mark. You guys, can I make up another letter out of thin air? I, K, L, L, W. How about H's? Oh, I forgot. H has got to range from somewhere, like from 1 to yeah, I think it's the number of columns of first matrix. And I think this is just simply the result of multiplying together A and B. So you guys, please look at this and attack me. Am I doing okay so far with my subscripts? All right, if I am, then I think if I really choose to do this, I can reassociate multiplication here because these are all real numbers. And if I multiply together my B sub B, my B sub HK, and my C sub KJ, then I think really what's going on is that the index variable is changing is the number of columns at first, rows at second. I think it's going to be changing in terms of K range from 1 to P. So I'm going to now put the sum of H equals 1 to N out here because technically speaking, look, H is not changing. K is what's changing, not H. So I'll sum on the outside, and I'll take the A sub IH's, which has nothing to do with K, meaning every single one of these terms has that as a factor. I'm going to pull it out. That's just a distributive property. And pulling it out, I've got my A sub, I lose my subscripts. Is that IH? It's just that when you take a peek at what's in this set of parentheses, that's nothing more than the result of multiplying the matrices B and C. Oh, I forgot. There's another multiplication operation. I guess I'm pre-multiplying by the matrix A. That is the arbitrary element in the product matrix in the ith row, jth column. I just manipulated the subscripts, that's all I'm doing.
So were you able to put the C sub kj next to the B, like when you rewrote for the second line?
Yes.
Because the sum isn't interacting with the K, or the H sum isn't interacting with the K sum?
That's exactly the point.
Okay.
That's why I'm able to pull that ASIP stuff out as well.
Okay.
I agree. Does anybody else agree? Yes.
Fine. I'm just really confused. After you wrote your first term there with the two sigmas out in front, how did you go from there to the next step? Where you, I guess, regrouped certain things? I'm just confused.
Can I put in the middle step? So then I'll confuse you further, I'm not gonna raise, but can I put an equal sign here, we'll talk about it, and from there it goes from here. So trying to insert an extra step. I was just suggesting that, in the end, I really do want to talk about the product of this and the whole thing here. And so I know I want that subscript in between to be the case. And so all I'm suggesting is, let me get these K's together. Now to do that legally, I can talk about B sub HK times C sub KJ, but you gotta confess, when it comes to this particular product, with my definition of multiplication of matrices, H is staying fixed, J is staying fixed. It's really the K's that are changing. And so I think I wanna look at the sum as K range from whatever it does to whatever it does.
Okay, but your B was locked away in the previous sigma equation. I don't think you can just multiply them together.
You can't multiply what together? What two things?
Your arbitrary B element and your arbitrary C element.
Gotcha. I disagree completely for this reason. By the way, I'm not finished, so don't go there. Isn't this a really big sum?
Yeah.
Product here, plus another product, plus another, and I think in this product, I've got a lot of B's in there. I'm just starting to see stuff in. So I do think I've got a bunch of terms involving B sub something times C sub something. I was just quantifying whether something's work.
Yeah.
Because they really do represent a really big sum, even though I'm not writing it such.
So you just distributed it into C and then.
That's exactly it, yes. And I just maintain I might have made a mistake. Watch. I might have made a mistake. Because I think I should have, let's see, what did I have sum K range from 1 to P? I should have my A sub IH's. Oh, but wait a minute. This sum's ranging over K's. This isn't it was K. So I think for all these terms for a given I and a given J and a given H, the K's are changing, but that's not changing at all. It's the same darn factor in every one of the terms. Can I just factor it out? But don't forget, in the end the I's will change because I've really got to be summing as the H business changes. Okay, maybe being a little goofy is no different than my next line, but at least when I wrote it, I was talking my way through this. Is that a little better?
Yeah, it was just the distributed property stuff that was confusing.
It's because we're not used to just looking at the glance and seeing it the way it's really represented. We're used to seeing it expanded form. Anybody else? Because you did kill me on the clock, with you wanting to take so long with the quiz.
So,
Boy, it sure is nice and variety.
so I saw the actual one, and looks nothing like mine.
Well, see,
So
I
if
think-
we did it without
I
using
found-
sigma notation, is that passable, or is that,
Well, technically speaking, that's what's meant.
Yeah.
Remember, I'm not quizzing you on the previous day's material,
okay,
although I tricked you this time.
yeah.
I think, well, where's the quiz? Oh, shoot.
Brought it down.
Is this?
Yep, that's it.
Mhm.
Sorry, I got rid of it. Now, if you're gonna not use yesterday's material, my definition of multiplication component-wise, you give up, and you just say let A be a 2 by 2.
Yeah.
Or 3 by 3. And you go through the regular routine because you've done that well before you entered this course.
I did sigma notation.
And I think if you're gonna be sophisticated, if you want to use sigma notation, I think life's easy. And you can be general. You won't restrict your attention to just 2 by 2s. I think you could have said, take this matrix right here, and look at an arbitrary element in it. I think as a result of multiplying two matrices, so I know I got the sum as k ranges from 1 to n of my a sub I k times, oh, bunch of stuff, b sub kj plus c sub kj. plus D sub kj. Yeah, Chris.
I got confused on the notation, but I think I'm okay now. But what I thought before was that the notation on the left meant the matrix whose arbitrary element.
It is not. I think the
is
notation,
arbitrary element.
thank you. I think that the notation of the brackets or parentheses, subscript ij means you're discussing an arbitrary element. And the arbitrary I throw, arbitrary j is the column of this whole resultant
Are
matrix.
you gonna mark me off for that?
I'll give you leeway today, but certainly by the next exam, you'll have it down pat.
So are you gonna ask stuff like this on the next exam more so than just solving matrices? Yeah. And would something like this just be, you'd expect us to know these proofs for like all of
You
these?
don't know anything, you just know your definitions.
Well, yeah, but I mean, so you'd expect us to know these proofs for everything, right? So,
Do the proofs.
because obviously if I did that on an exam, I would run out of time.
That's the whole point.
Yeah.
You guys check this out. You look at my notation. Somebody tell me what the dimension of this matrix is.
Isn't it just an element in a matrix?
It's a real number.
Yeah.
It's not a matrix. Do you guys see my point? Ah, shoot. That means everything above my two fingertips and in between are just real numbers. We already know we got a distribution, proper multiplication over addition, and the real numbers. Let's exploit it. I got the sum of k ranged from 1 to n of a sub I k b sub k j plus a sub I k c sub k j plus my a sub I k d. I know my alphabet. B. I should use lowercase d to my point.
I was wondering why they spelled two ways.
I'm selling the whole thing. But shoot, you guys are Math 30 experts.
Some of the sums.
I misspoke. I talk about this in Math D. You're Math D experts, and you know the sum of the sums is the sum of the sums.
Talk about this in Math D.
Yes.
That's so wonderful.
So I think I got the sum is k range from 1 to n of this product. Plus the sum has k range from 1 to n of this product. Well, not that one, but this one. Plus the sum of this product. The heck with it. Let's cut to the chase. This is nothing more than an arbitrary element in this product matrix. This is an arbitrary element in this product matrix, and here too. It's just I'm adding them together, and I'm talking about the arbitrary element overall and the I throw j column. So if you were to use yesterday's material in terms of multiplication matrices, your life is so much easier.
Okay.
But you didn't have to. I just expect you to rely on what you know.
And it was.
That's not bad, is it?
So we can expect a bunch of these on a test.
I would say
Maybe just one.
a bunch of them.
Maybe just one.
Or something.
One or so.
Okay. And could you tell us which ones that we should really learn?
All of them.
Well, see, I'm serious. I think you should learn none of them.
None of them?
I think you should just shut your mind down, know the simple few basic definitions, and use them to answer these questions.
Okay.
I mean, to me, that we will ramp up.
Okay.
So we're out of time. For those of you who are interested in honors, I need to talk to you now. I need to go to my office and take care of some business. Okay?
Okay.
Don't worry, you don't do any work. I've done all the work for you, all of it, except for get some personal information.